Hello, this is Dr. Joe Trout from the physics program at the Richard Stockton College of New Jersey. In this lecture, I'd like to discuss your final project. So for your final project, you'll be assigned to 2 locations in the world, and you'll be asked to research their climate and the climate trends of the area. You'll know which locations you'll be assigned by looking at your grade sheet. When you look at your grade sheet, you should see 2 columns at the end of the grade sheet labeled Final Project Data File 1 and Final Project Data File 2. And there'll be 2 files listed. These files are on BB Vista under the folder Final Project Data Files. So for example, let's say one of your files was file 16. You could open this folder and then look for file 16. If you click on the file, more than likely it will open up the Excel spreadsheet for you. Depending on how your machine is configured, or if you're using a computer on the campus, some dialog boxes may come up. This dialog box is telling me that Microsoft Excel is not set up as the default program for viewing this type of file. I don't care, so I'm just going to go ahead and close this dialog box. You'll also want to enable the editing. Once you've done that, you want to save the file, and you're going to save it either to a USB drive or to the desktop if it's your own machine. If you're working on someone else's machine or a machine at the campus, make sure you save it to a USB drive. This is important because if you do a bunch of work and you don't save it to a USB drive and it is not your computer, the file will disappear and all of your work will be gone. So I can't stress this enough. Unless it's your home computer, save the file to USB drive. This is my home computer, so I'm going to save it. And I'm just going to put the extension, I'm just going to make it file 16 and add my name to it. You can call it whatever you'd like. I have a file that already existed with this name. I'm going to go ahead and overwrite it. Right now I'm going to enlarge the fonts so that you can see it better. You do not have to do this step. Now what you should see when you open up your file is on the first line it says station ID, station name, country, the longitude, the latitude, and the elevation. So the location I was assigned is Sapporo, Japan. It has a latitude of 43 degrees and a longitude of 141 degrees. What comes next are monthly averages of the temperature in degrees Celsius. So this record for Japan begins in 1889, and in cell E5 is the average temperature for January in the year 1889. You will have approximately 100 years of data. Some of you will have more, and some of you will have less. This record goes up to 1991. What follows next is precipitation data in millimeters, and you will not have to use this. So we're not going to use this for this assignment. So if you remember, when we're talking about the climate, we're talking about the average weather. And in the United States, we average the weather over 30 years. But for this project, I'd like you to average all of the data you have. So if you have 100 years of data, use all 100 to find the average. Now you're going to write a short paper that's 3 to 10 pages long, and in it you're going to discuss the climate and the climate trends. The first thing you want to do is find out where your location is and what this area looks like. So what the topography of the area is. The easiest way to do this is to open up a web browser and go to your favorite mapping routine. So I'm going to go to mapquest.com because that's the one I like. And I'm going to search for the latitude and longitude. In MapQuest, the latitude has to go first, and then a space, and then the longitude. And it looks like MapQuest found it. So I'll go ahead and hit return. And by default, MapQuest gives you a street view. Now that's not going to help with the climate to distinguish the climate at all. So let's go ahead and we'll zoom out from here. And the further we go out, finally we see that we're actually on an island. So that's significant. So we're on a location that's surrounded by water. While we're here, we might as well go ahead and take a copy of this map and put it into our report. So you can go ahead and open up a word processor, such as Microsoft Word, and go ahead and open up a blank document, and we'll go ahead and paste the picture in. So there's a couple hundred ways that you could paste the picture in. What I like to use is the snipping tool. So if I go back to the start button and I type snip, the snipping tool will come up. And I can say new and highlight the area that I'm interested in. If I don't like the picture, just hit new again. From here we can do an edit and copy. and we can paste it into our document. So this is the map of it, the area. Some people like to put the satellite view in also. So if you click on the satellite view, you get a little better idea of what's going on. So there's some mountains here and some other things, and you can, you get an idea of exactly what the terrain looks like. Once again, if we go back to our snipping tool and click on New, we can take a picture of this. We can cut out a picture of this and put it into our report. By the way, there's a copy of a sample paper on the website, and it was a paper that was done by one of my students in another class, and it's a very well done paper. So now let's go back to our data, and what we're going to do is look at the data and try to figure out what the climate is. And we're just going to look at the temperature data. So I'm going to go ahead and shrink this down. So first I'd like to see how the temperature trends during the year. So what the temperature outlook looks like during the year. So what I'm going to do is take an average of all these years, and I'm going to plot it against the month. So I'm going to do a plot of the average temperature per month against the month. So I'll write time here, and the time is in months, and there's 12 months. By the way, there's a shortcut that means you don't have to type in all the numbers, excuse me. And if you know it, you can go ahead and use it. And we want the temperature. And don't forget the temperature is in degrees C. And let's find out the temperature, the average temperature for January. And once again, we'll use all of the years we have. So from 1989 to 1991. So we'll click on our first value, and then holding the mouse button down, we can drag down to the bottom, and that tells us what our average temperature is in January. It's about negative 4.8 degrees C. We'll do the same thing for February. So we type equals average. We move up to the top of the column and click on, in my case, F5, and highlight down to the last value in the column. And it's negative 3.9. You can go ahead and do that 10 more times, but instead, there's a function in spreadsheets known as the fill down or fill left or right function. And if you look, there's a little green box in the lower right hand corner of this cell. And if you move your cursor over it, you'll notice that the cursor changes from a fat plus sign to a thin plus sign. Once it becomes a thin plus sign, you can click and hold that button down. So click with your mouse button and hold it down, and then drag it to the right, and it'll fill in those averages for you. So you notice that it just did the average for each one of these. Okay, so now we want a plot of this. Click on the time, hold the mouse button down, and highlight all of these values. Then go to Insert and Chart. And here we have what the temperature looks like during the year. Now I'm going to drag this over so we can enlarge it a little bit and have some room to work with. All right, and we have to make a couple of adjustments here. The first thing we want to do is change this title. So we want to say that this is the average, and spell average right, monthly temperature for Sapporo, Japan, okay. We also need to put some axis labels in here. So you might notice that if this chart is highlighted, the chart tools show up. And what we can do is add chart elements. So this is under the Design tab, Add Chart Elements. And we'll go to Axis Titles. We need a primary horizontal. And we need a primary vertical. So our x-axis is going to be time in month. And our y-axis is going to be temperature in degrees C. Now what we want to do is copy this and paste it into our paper. So now we have an idea of what the temperature looks like in Japan as the year progresses. So we can say that our coldest temperature is in January, and that's about -5 degrees C. And our warmest temperature is in August, and that temperature is 21.8 degrees C. So you'll write that in your report that that's what you found the temperature to be. I'd also like you to go and find out what other people think. So for instance, let's look at the climate. Right, we can search for the climate for our location. And there's a couple of good places to go to look for the climate. One place is called World Weather Online. It doesn't have every location on Earth, but it does have the location that I'm working on. So what you'll do is summarize what they say about the weather. So they say that it strongly resembles Northern Europe, and that in winter, December to March, they receive more snow and colder winter temperatures between -1 and -8 degrees C. They also talk about, they give you an outlook for the summer and they give you an outlook for the winter. So you'll read these and put it in your paper. And if you want, you can even include this chart that they had, as long as you make sure you footnote everything and say where you got it from. Okay, so you could either click on it sometimes and just save it as a picture, or if you want to save time, you can just use the snipping tool again and look for another picture and edit and copy it and paste it into your paper. And what you want to do is discuss whether the data that you have analyzed looks like the data that they have analyzed. Now what they've done is looked for the average high and low temperatures. So you figure the average is somewhere in between these. And you can discuss if you think that the data you found matches what they think the climate is like. Make sure you look at the model paper, because you want to make sure that you have a short statement about which each one of these pictures is and where it came from. And you also want to make sure that everything is footnoted accordingly. So now we have an idea of what the climate is like. Next we want to see if the climate is changing, or if we think the climate is changing. So let's go back to our spreadsheet. This time what we're going to do is we're going to look at the average max and min temperature per year. So the average, the maximum, and the minimum temperature per year. So the minimum, the average, and the maximum. Excel has a function called min. So instead of looking through and searching through here, right, we can see that the minimum temperature is -6.8. But instead of going through each year and looking to find it, we can just use the minimum function. It also has a maximum function, so equals max, and we highlight from January to December, and it tells us what the maximum temperature is. And of course, we'll find out the average for the year, and we've already used this function a couple of times, so I'm sure you know how it works. Right? We'll just have equals E5 to P5, and we can hit return. Now what you can do is highlight all three of these and then use this fill down box. So don't forget, wait for the cursor to change from a thick plus sign to a thin plus sign. Then click with your mouse button, hold the mouse button down, and drag this downward. Okay, so now what we want to do is we're going to plot the max, min, and average temperature versus the year. So go over to the year, click on the year, then highlight this column. This time we're not using the fill down box, right? We're just highlighting. Hit the control key, then move over to your max, min, and average column and drag it down. Okay, so now you should have those three columns and your year column all highlighted. Then you can go to Insert and a Scatter Plot. And we get something that looks like this. Okay, we're going to go to the chart title and change it to be something, say Climate Trends and the location. We also need to add in our axis titles. So we have a primary horizontal axis and a primary vertical axis. This time our x-axis is time, but instead of being in month, it's going to be in years, right? And our temperature, our y column, is still going to be the temperature in degrees C. And in your paper, make sure you spell everything correctly. For instance, temperature has a P in it. So now what we want to do is see if we can get any information from this graph about how the climate is changing or if it's changing. So for instance, the average temperature isn't the exact same thing every year. That wouldn't make any sense, right? There must be some variation. What we'll do is insert a trend line. So what you could do is click on one of the data points and then using the opposite mouse button, the right-hand side mouse button, we can add a trend line. And at the bottom, we want to make it a linear trend line. And we want to display the equation on the chart, and we want to display the r squared value. So what this does, like you did in your homework one day, is it tells you what the slope is, it tells you the y-intercept, and it tells you the r squared value. By the way, you can make this bigger if you like. Okay, so you can see it. The r squared value, if it's a perfectly straight line, and your line matches every data point, r squared will equal 1. This line isn't that great of a line. It doesn't fit the data exactly, but it does a pretty good job, and it's the best we can do. So, what this means is that it looks like, since there's a positive slope, that the temperature is increasing about 0.0083 degrees C per year. So every year, the temperature is going up about 0.008 degrees per year. This value, the negative 7.95, what it means in a mathematical sense is that it's the y-intercept. So this would be the temperature, the yearly average temperature at year 0. Okay, that would be true if this trend kept on going back to year 0. right? In reality, for our purposes, it means nothing. It means absolutely nothing. So the only thing we can take away from this is that it appears that the temperature is increasing, the average yearly temperature is increasing about 0.008 degrees C per year. Now, climate not only discusses the average values, but also the maxes and the mins. So let's go for let's add our trend line to our maximum. Once again, we want it to be linear. We want to display the equation on the chart, and we want to display the r squared value. And once again, we can make it larger so everybody can see it. What this tells us is that it looks like the maximum temperature for the year is increasing about 0.0078 degrees C each year. So in 100 years, the maximum temperature would increase by 0.78. And in 1,000 years, the maximum temperature would increase 7.8. Okay, and then we want to do the same thing for the minimum temperature. So we'll display the equation on the chart and display the r squared value. Then we'll click on it, and if you want, you can make it the font larger. So it looks like the minimum temperature is increasing about 0.012 degrees each year. So what does this mean? This means that on the average, the temperature is increasing, and the maximum temperature is increasing. So the summers are getting hotter, and the winters are getting hotter. Okay? Not everyone's will look like this. In some places, you'll find the summers getting warmer and the winters getting colder. In other places, you'll find both the summers and the winters getting colder. Okay, so you need to go ahead and look at this. So what are we going to do now? You probably guessed. We're going to take this, we're going to make a copy of it, and we're going to paste it into our paper. Okay, sometimes you'll have to make some corrections to your paper. In fact, I would like for you to just leave it large enough to be seen and just make the graph bigger like we just did. Okay, so in your paper you're going to discuss what you found from this analysis. So what I found was that the average temperature appears to be increasing each year by about 0.008 degrees C. The summers are getting warmer by about 0.0078 degrees C each year. And it looks like the winters are also getting warmer, and they're increasing about 0.012 degrees C each year. Once again, this value is the y-intercept. It's the average temperature at year, well, this would be the maximum temperature at year 0 if this analysis could go back to year 0, but that wouldn't make any sense to do that. Okay? So, after you look at the location and you use your data to try to figure out what the seasonal temperature variations look like, By the way, not all places will look like this, right? Not all places will have a cold winter and a hot summer and a cold winter and a hot summer. Okay? India, for instance, will look quite different. Okay, and that's because of the monsoons. All right? So you figure out what the seasonal temperature variation looks like, and you write that into your paper. And then you look online and see what other people think the seasonal variation looks like. Now online, you might just be able to get the average high and the average low temperature. But you can compare it to your analysis and see if they're getting roughly the same answers that you got. Then we're going to look at the climate trends. So is there global warming going on, or is there global cooling going on? And we'll plot the maximum, the average, and the minimum yearly temperature. We'll go ahead and do a trend analysis. So we'll insert a straight line to fit the data. And from that, we can look at the slope. And if it's positive, that means that it's getting warmer. If it's negative, that means that it's getting cooler. Okay, the last thing to do is to go ahead and look at climate trends and see if there's anything you can find about that. All right, you don't have to use the internet. You could go to the library and look for books that would tell you the same thing. But for this case, you could go ahead and just do the research on the internet if you'd like. Okay, you could go ahead and look up and see if anyone has done any climate analysis, and see if they believe that the climate is changing in this area. And you can talk as to whether your data fits the data that they have, or their analysis fits your analysis. Okay? There's a sample spreadsheet on the website for you to look at. There's also a sample paper on the website for you to look at. Just one last thing before I end this lecture. I want to go ahead and look at one of the files from India. So here we are in India, and what we're going to do is we'll look for the monthly averages. Okay, so what you'll see is that in India, instead of looking like a cold winter and a warm summer and a cold winter and a warm summer, what we actually have is a hot rainy summer and a hot dry winter. Okay, the reason for this, so once again, this looks a lot different Sorry about that. This looks a lot different than Japan, right? In Japan, we had a cold winter and a hot summer and a cold winter again. And here, what we have, it looks like two humps, right? The reason for this we'll discuss in one of the lectures, but if we go ahead and look at India, right, and this is 17.7 latitude and 83.3 longitude. Okay, and this is in India. Once again, it shows us the street view, but I'll go ahead and back out. So this is what India looks like. What there are mountains here, and these are, it's covered by water on this side, on both of these sides. So it kind of looks like a triangle with water and mountains. Don't forget, water acts very differently than mountains. Okay, so water looks very differently than land does. Okay, and what will happen is that during the summer, sorry about this, during the summer, we'll get more direct sunlight and the land will heat up very, very fast and we'll get breezes that come in off the water. During the winter, what happens is that the land cools off faster and the water stays warm and the air rolls down these mountains. Okay, and we discussed that in detail in, I believe it's chapter 13. Okay, so I hope this will help you with your final project. If you get stuck at all, just save the spreadsheet and send it to me, and I will gladly try to help you out or talk you through it. Okay, and if you have any questions, please email me and we can discuss this final paper. All right, thank you, and I'll see you next time.